Do you know how C# knows which method implementation to call when you call a virtual method on an object? First of all, it is not C#. It is the .NET Runtime, the one that resolves method calls. But a question remains. If we had a base and a derived class, it would only take a minute to bring some hard questions. The base class would define a virtual method, letting any derived class override it, giving it a different body. There could be another virtual method in the base class, but without overriding the derived class. Both classes would then share the same implementation of this method. I will now instantiate a couple of objects and you will try to figure out their differences. I will give you a moment to think. What do you see? The first object is straightforward, an instance of the base class assigned to the reference of type base. But then comes the puzzle. An instance of the derived class assigned to a reference of type base. This is legal in any object-oriented language and falls under the so-called object assignment rule. You can assign an object to a reference to that object's actual type or any base type. The third object exercises the last remaining possibility, assigning a derived object to a reference of its actual type, derived. That was the lesson about legal assignments. But now comes the lesson about method invocations, which is the theme of this demonstration. I will call the same virtual method on each of these three references. I will not say three objects because I might not know how many distinct objects there are. All I can see are the references of certain types pointing to some objects. That is when the .NET Runtime jumps in and resolves which method implementation to invoke in each of these three lines. Let me run the demo and then we will discuss the results. Only the first call was made on the base implementation, and the remaining two calls ended up invoking the method's override. The critical information is in the middle. A call made on the reference to the base class has effectively called the method defined in the derived class. How? When you figure out how that happened, you will know virtual methods. I have moved the testing code to a helper class, and now we can focus on the base and derived classes to understand how the .NET Runtime sees them. Every object, not class but object, has access to a few separate objects via the references injected into the object during its creation. One is to the object's runtime type. The other structure is the so-called virtual method table or VTable. You will now learn the role of each of these two. The type is not affected by the reference to which we assign an object. It is the object's most intimate information. Every instance of the base class will have the reference to the same object that explains the base class itself. And every instance of the derived class will possess the reference to another object that explains the derived class. You can access these objects easily. Just call the GetType method on an object and you will obtain the type object. If this is your first time thinking about how .NET Reflection works, this code shows the answer. A call to the GetType method starts from the reference to this object, whatever that is, and follows the reference to the type object stored in this instance. No matter what reference type you have assigned this object to, whether it is a base or a derived reference, the type object will be resolved from the object. Now that you have got that principle right, you are ready for the scariest part of the object's layout, the VTable. Each type comes with its own table of virtual methods. Not each object, but each type. Therefore, all instances of the base class will share the reference to the same base VTable. This table will have as many entries as there are virtual methods on the class, either defined on it or inherited from its base. And so the base class's VTable will have two entries pointing to actual implementations of the two virtual methods. This part was straightforward. The part that will twist your mind is in the derived class. This class also has two virtual methods, both inherited from its base. But when the time comes to populate the address of the actual implementation of the first virtual method, the derived class has something to say. It will put the address of the method we added to the derived class. That is how the compiler implements overriding. The override keyword in C# code implies that the corresponding entry in this class's VTable will point to the new implementation. The second entry belongs to the second virtual method inherited from the base. The derived class did not override this method, therefore the compiler will copy the implementation address from the base class's VTable. That is what happens when we do not override a virtual method. How does calling virtual methods work then? Here I am calling the virtual method on one of the objects. The .NET Runtime jumps in and looks for the VTable of the object on which the call is made. Since it is the base class instance, we would end up in the base class's VTable. Then the runtime picks the entry for the virtual method we have called. That entry would lead to the concrete method implemented in the base class. Let's raise the bar and make another call, this time on the derived class instance assigned to the base class reference. The first step is to ignore the type of the reference. The runtime does not bother with that. It goes straight into the object, poking out its VTable. Since it is the derived object, we would get into the derived class's VTable, which differs from the base class's VTable. The difference is precisely on the method we are invoking in this line, so the runtime will resolve the call to the concrete method in the derived class and pass control to that implementation. What if I called the same virtual method again, only this time through the reference to the derived class? Nothing. The type of the reference is ignored and only the object is observed. Therefore, this call will execute the same as the one above. Let me run the demo. You will see what I said is true. Now you know how virtual method polymorphism works in C# and any other object-oriented language. However, virtual methods are not the only means of doing polymorphism. I could have defined an interface too. For the base class to implement this interface, it must also define the second method. But look, this method is not virtual. And yet the runtime will do its magic again to resolve both methods dynamically at runtime. While this demo is over, I guess the question of how the interface methods are resolved at runtime, especially the non-virtual ones, will keep you awake at night.